Alright, in this video I'm going to try to do derivatives, which is the next, if not the first, thing you'd learn in calculus. So basically the way you'd write it is d over dx. This just means with respect to x. So if we have this little form here, d over dx, and we have, let's see, x squared, which is the first thing you'll probably learn is x squared. And you're like, alright, well how do I find the derivative, right? So what you do is you just take this number, you drop it down here to get 2x, then you take this number and you minus it by 1. And you're like, oh, alright, so that gives us 2x, 2, and then you say, okay, well 2x minus 1 is just 1. Anything raised to the 1 power is just itself, so it's 2x. It seems pretty simple, but this would probably be the first problem you learn, or if you're taking pre-calculus, you definitely learn this there too. So let's say if we take the derivative with respect to x, and you can put it up here, x to the third, whatever. So we got x to the third, so we drop this down. I'll just write out here though, x to the third. So x to the third, that's what? 3x to the second, right? Because 3 minus 1 is 2, and then we just take this one, drop it down, and that's it. That's that for that one. Now what if we have 2x to the third? What does that equal if we want to take the derivative with respect to x? If we took it with respect to t, then the x would just be a constant, and we'd get this, well, we could find the derivative, and then we could say dt dx, because that means that we still need to find the derivative of whatever t was. Alright, but let's just do it, of course, with respect to x, keep it simple. And so we drop this down, and since there's already a coefficient there, you can multiply them, so it's 6, oops, oh wait, I'll just do it like that, 3 times 2x to the second, and that equals 6x to the second. Alright, now what if we have a negative exponent? So we can do the derivative with respect to x. I'm just going to see how many I can get out and how many videos I could do on derivatives before I have to go to work. 2x, well I'll just change it up. 4x, I'll just make it simple, it's in the negative 1. Alright, so we drop this one down, multiply it by the coefficient, and of course up here we have a coefficient of 1. Right, and the same thing up here, we have a coefficient of 1, so but you don't even need to write it. But this one, 4 times negative 1, so it's negative 4x, and then we decrement this one by 1, and negative 1 minus 1, people like to get confused, and you want to write a 0, excuse me, you want to write a 0, but you decrement negative 1 minus 1, negative 1 minus 1, or plus negative 1, same thing, negative 2. And that's what we do, negative 2. And of course another way to write this, if you have a negative exponent, is you could put it in the denominator and make it positive. So you could also write 4 over, or negative 4 over x squared. Alright, and let's see if we want to take the derivative of, let's just say, square root of x. Well, square root of x is just x to the 1/2, right? So it's the same thing as, well, I should write the derivative. Same thing as the derivative of x to the 1/2. So we take this, we times it down here, so we get 1/2 x, and then 1/2 minus 1 is negative 1/2, right? Or again, since it says a negative exponent, we could write 1/2. Well, and then 1 over x, and then this would become a positive 1/2, so 1 over square root of x. Or we could, these are really multiplied, so we could say 1 over 2 square roots of x, and that's the answer for this one. Alright, that's only about 5 minutes. Let's see if we can do some more. Let's say we want to take, I don't really want to get into trig functions yet, but well I'll wait. So we can see if we take 3x plus square root of x minus 2. We want to take the derivative of all of this. Let me change colors here. Let me just write that. It's not a very different color, but we get something a little different. Alright. So if we want to take this right here, then we just take them separately. It's really the same thing as the derivative with respect to x of 3x plus the derivative with respect to x of the square root of x minus the derivative, we don't even have to do this one, the derivative with respect to x of negative 2. This is just a constant, it doesn't have an x. So derivative of a constant, and this is probably a good idea since I accidentally made this, is 0 of any constant, even if it's infinity, although it's not a real number, infinity, and you won't see that minus infinity usually unless you're taking a limit and you're doing anyway. Alright, so you take the derivative with respect to x of 3x. Remember, this is really just a 1. So we get, oops, I don't need to write that. So we get 3, right? You drop this down, multiply it, it's just 3, decrement it, it's x to the 0. I could write that and then I'll simplify it later. It's x to the 0, and that's just 1. 3 times 1 again is just 3. Alright, plus the square root of, so that's just x to the 1/2, right? We just did that. Although I shouldn't have written it that simply. I should have wrote. Well, let's find out. What do we get for x to the 1/2, or x to the square root of x? We got 1 over 2 square roots of x. I'm just going to write it like this, that way I can simplify it. 1 over 2 square roots of x, or keep all the derivatives gathered here, down here, and then minus, and then derivative of a constant, like I said, is 0, so minus 0. And I probably should actually do it like this, plus negative 2, since I already have the negative here. So plus 0, which doesn't change the value, but it makes it more correct. Alright, so like I said, 3 to the x to the x to the 0 times x to the 0 is just 3, and 1 over 2 square roots of x, and that's it. And that's our answer. Let's see, it's about 8 minutes. Let's see if I can do another problem. Well, I like how I brought it out like here. Like if we say, okay, let's try to do another constant. Alright, so the derivative, well, I can change it to derivative with respect to t. That way I know what I'm taking the derivative of. And if I have 4t plus 6, it's like, oh, alright. I can do it separately. It doesn't really matter because I can do it in my head. And you can get derivative of 4t, you just treat it like as if it was x. This is really equal to when you're taking the derivative, right? Derivative of x, 4x, it's just telling you it's this is your arbitrary number, or it's going to be your value that you need to input rather of your function. Let's see, plus 6, it's the same thing. So if we were to take the derivative of this one, since we've already started it, let's do, okay, so take this one, it's really a 1, drop it down, you get 4t, you minus it 1, it becomes 0, right? So it just becomes 4, and actually that's the entire answer because the derivative of a constant is just 0. And that makes sense because when you find the derivative of a function, you're asking, okay, what's the slope? And you're saying, what's the slope of, say if it was 6, and that would just be, y equals 6, right? I don't want to confuse you too much, but you're just at y equals 6, or a graph right here. This is 6, and you're like, what's the slope? Well, it's 0, right? That's the idea. If you got 4t, it might look something like, let's see, 4 times. So 1 would be 4. 2 would be 8. Actually, yeah, see, you would have, your slope would be 4, and that's how you do it. That's the idea. And even when you have something like, I don't want to make it, it's about 10 minutes. Well, I'll make some more in the next video. So this one is